So we've covered a standard drilling cycle. Let's have an in-depth look of how a Peck drilling cycle works using the G83 command. The standard FANUC G code for a Peck drilling cycle is usually G83. This can change depending on the different types of controls your machine has, but using the FANUC standard, this is normally the G code that we use. Adding the X and Y coordinates on the G83 line is optional. The way I normally program is I move the cutter into position using a G00 command a few lines above the G83 line. By using this technique, I don't need to add the X and Y positions because the tool is already in position. But we can use X and Y coordinates on our G83 line to define the position of the first hole. Assuming we have set the datum on the surface of the material, our Z line on this move defines the depth of our hole. After each peck of the drill returns to the same position. We define this position by using an R value. This is our retract value. If we are drilling into a blind hole, in other words our hole doesn't go right the way through the component, we can add a dwell value. This is so the drill stops at the bottom of the hole for a few seconds that we define with a P value. This is used to clean up the bottom of the hole, and it also adds to greater dimensional accuracy, which allows us to have greater repeatability on the holes, so the depth remains more constant. The Q value in this case defines the depth of each peck. This is the amount of material the drill will remove on each peck before it rapids back to the R position. And finally we have our feed rate. This is usually defined in millimeters per minute. So, what does this look like inside a program? Well, let's have a look. You're already familiar with our part, and already familiar when we drilled our holes, so we can keep the program pretty much the same and just change the G81 line to the G83 line to demonstrate. So let's have a real world look at how the pecking cycle works. G83 defines our pecking cycle. It's very similar to the G81 cycle, as you'll see in a second. Our Z dimension defines the depth we wish the drill to go on each peck. In this case, it's still 12mm, as I'm assuming the billet is 10mm thick, and I wish the drill to come out the other side of the billet by 2mm. Our R value defines our retract value. This is the distance the drill retracts to after each peck. A value of R 1mm brings the tool a millimetre above the surface of the material after each peck. A P value tells the machine how long to dwell at the bottom of the hole so we can clean up the surface. On some control systems, especially the newer ones, this is defined in milliseconds. So a value of P 1000 milliseconds is equal to 1 second. This may also be shown as P 1.0 on some controls. The Q value. Now the Q value defines the depth of each peck. So each time the drill pecks, it will move 3mm until the hole is complete. And finally we have our feed rate. 50mm per minute is just for demonstration purposes. This will change greatly depending on what material you are cutting. So what happens if we have a clamp in the way and we wish to occasionally retract our drill further than the R1 value of 1mm? Well, it's the same as the G81 cycle. And by that I mean we can add a G99 and a G98 command in the program to retract our drill further to avoid any obstacles. This is the same as we discussed when I was explaining the G81 drilling cycle. So the operation of a G83 Peck drilling cycle is very similar to the G81 cycle, apart from the fact we can add a Q value to add a peck depth on each drilled hole. A pecking drill cycle would usually be used when you're drilling a deep hole or when you're cutting hard material. It is also known as a chip breaking cycle, to break the swarf up to stop the drill getting overloaded with swarf and breaking.